Okay, hi everybody. Welcome to going over your assignment calculations from last time. All right, so this was part of your work that you had to do after you watched the Ed puzzle from last time. And so in each of these cases, you're going to find that we actually have to be good at this, we have to be able to label all of our pieces. So, for instance, we are given in this first sentence of this one, we are given a volume and a pressure. And then we are told something about an altitude, and that's a distractor because we don't have any altitude in any of our calculations. But then we are told a second pressure, and we're asked for what is the resulting volume. And so many times we have to figure out what equation to use, but I will propose to you that figuring out the equation is really no more than just taking a look at the combined gas law and deciding if there is any part of it that remains constant. In this case, for this problem, temperature was constant, so we would get to leave it out of the problem. So in this case, since temperature was constant, I get to cross the temperature out of the problem, and that's where I got this Boyle's law equation from. And then it's a matter of plugging everything into the equation and solving appropriately. Many of you told me that it was 1,000 milliliters, and that was totally okay there. All right, so let's go on and check with question number 2. In question number 2, it is another one similar to like number 1. You had to be able to solve appropriately. And what I saw mainly that happened in this type of problem was that there was some confusion about how to actually do the math. And so after we get all of our variables labeled, then we actually have to do the math correctly. And if you got this one wrong, it was because you just didn't do the math correctly. So that was an issue. But so make sure that, as you can see here, you multiply P1 and V1, and then you're dividing by the V2, and that gives you your P2. And you did have to round to appropriate number of significant figures there as well, and have a unit label as well. A lot of people left off unit labels. Please, please, please remember those. Okay, now why is this so important that we go over these problems? It's mainly because your quiz that you're going to be taking in class next time is going to be over this type of calculation. And so you will want to, while you will get to look at notes, you will not get any repeat problems or even the same problems as anybody else. So you are going to need to be able to do the type of math that these require you to do. Okay, let's go on and look at one that's slightly different. Let's go ahead and take a look at number 3. Number 3 onward is going to be where temperature has a place in this. And so you are going to have to remember to convert your temperature to Kelvin. And that is a requirement anytime you're using temperature in a gas laws problem. So we have all our variables labeled. So there's our V1 and there's our T1, but we convert it to Kelvin. And then we finally have our V2. Whoops, get that one out of there. We have our V2, which is right here. So V1 and then T1 with 273 added to it. And then it's just a matter of plugging everything in the right place. Now you might be going, well, where'd that equation come from? Well, if we look at what we said in the Ed puzzle, we had V1 over T1 in Kelvin is equal to V2 over T2 in Kelvin. And if you think mathematically, this was these two things are the exact same thing as each other. They're the same equation. They're just rearranged differently. So there's that. So when you calculated, you should have found a Kelvin temperature, but you also had to convert it to Celsius to report not only the Kelvin, but also the Celsius temperature. If people were getting these wrong, it was because they were not converting to Kelvin. Okay, so let's go on to question number 4 then. In question number 4, same type of thing happened again. We had to label all our variables. We had to make sure that we were working in Kelvin, and we had to solve for Kelvin, but this is asking for a Celsius temperature, and if you got this wrong, it's because you did not convert back to Celsius. So you do have to remember to do that part for that particular one. All right, so our next one Number 5, things are slightly different now. Now we have a situation in which our volume is being kept constant, and we have a pressure and temperature to pay attention to. So in this case, where did we get this equation? We can use the combined gas law, which is P1 times V1 over T1 in Kelvin is equal to P2 times V2 over T2 in Kelvin. And when volume is kept constant, we get to cross out the volume. And you could have solved it this way, but you could have also solved it this way as well. Those two equations were the same thing mathematically. And then it was just a matter of plugging everything in and solving for the appropriate temperature in Celsius. It did ask you to convert it back to Celsius, which you did have to do. Now, something that you might be noticing is that if it asks you to convert back to Celsius, you do still have to do your math in Kelvin and then convert at the end. All right, let's continue on to look at number 6. Number 6 was a similar one to the last one, except that we were solving for pressure this time with our temperatures in Kelvin, just like before, but this time we had to do 2 temperatures in Kelvin. Again, if you got this one wrong, it is because you did not have your temperatures changed to Kelvin. Okay. Number 7 and number 8 both required a lot more work because they both were using the entire combined gas law. And so here we had a whole bunch of variables. This is a really good example of why you need to label your variables so you get them in the right places, and why you need to change your temperatures to Kelvin so you make sure that you do your math correctly. So there are my temperatures changed to Kelvin. If you did all your math correctly, then you did get the correct volume there. Okay. And then we get to one like number 8, and there was a lot of issue with number 8, and that is because of this terminology which you have in your notes, standard temperature and pressure. So standard pressure is equal to 1 atmosphere, which is also equal to 101 kPa, as you know from our original notes. And then standard temperature, is 0 degrees Celsius, which is also equal to 273, as you see there. So that terminology is what you needed to be able to fill in P1 and T1. V1 was given to you in the problem. And then you were told V2 and the new temperature, which was 30 degrees Celsius, which had to be changed to Kelvin. And then we solved for the pressure 2, which was then in kPa as long as we used 101. So there is your mathematics, and it should lead you to be able to solve for the correct answer, which came out to 394 after you rounded it correctly. Okay, so then we get finally to number 9, and this stumped a lot of people. This was the use of Dalton's law, where you had to add up the pressures. Total pressure was equal to the partial pressures of each of the gases in the mixture. And so if we needed the missing gas, in this case it was He, then we were going to have to subtract after we converted everything to atmospheres, which is what we did here. This only used pressures, and so we had to make sure everything was in the same unit label. In this case, the question asked for atmospheres. Okay, everybody, I hope that was understandable.